Okay, just a little test to make sure my microphone is unmuted, and it looks like, it sounds like it is. Okay, we'll go in a couple of minutes. Hey folks, it's T2sday. If you are here because of the title card, check out if I really am crazy or not. Thanks for checking in. It's for computer nerds, but hopefully folks who are ready to think a little bit beyond the PC, a little bit beyond CPU and RAM. So if you're a little bit of a nerd and you can put up with sort of the amateurishness of the digs, stick around a little bit. See if you like it. We often start here. The T2 Tile Project, building a hardware software prototype, the movable piece machine. What the hell is a movable piece machine? It's a different kind of computer architecture. Let's open up as we do these days by checking in with BV. BV was bored waiting for the new hardware. So, if my new floor sensors are already installed, said BV, again, how hard would it be to just hook them up? Well, said Seneca, rebuilding your brain isn't so easy. There's lots of numbers to keep track of each time, and I think the developers get bored too. Couldn't you do it? Asked BV. Well, it's not. Well, maybe I will, replied Seneca. Hey, Seneca, said BV, look at me. Look what I can do. Why, you've got a bit of a squint there, said Seneca. I'm a squinter. Ha-ha, said BV. Well, you see, now that's an example, said Seneca. The engineers were trying to get your eyes to go wider apart to help track red, but it looks like they got the wires crossed. Wires crossed, said BV. My eyes. See my eyes. Ha-ha. Look at me, Seneca. But Seneca had already busted out the mad Python skills and was hacking away at something, hacking, and in no time, or maybe a few days actually, Seneca was back all excited. Look at this, Seneca said. What's that? Said BV. It's your brain, said Seneca. It's my brain, said BV. Well, it's a description of your brain, really, said Seneca. It's instructions for making your brain. Okay, said BV. It's a mess, right? Said Seneca. It's very wide, said BV. Right, said Seneca. Exactly. But look at this. What's that? Said BV. It's your new brain description, said Seneca. Not wide, said BV. Kinda small? Well, it actually describes a bigger brain than that whole mess before, said Seneca. You position the whole crossbar and it figures out the individual positions. Wow, said BV. Neat. Just change one letter to flip a whole crossbar access. Cool, said BV. Smart. And you can specify automatic connections between crossbars too, said Seneca. Sold, said BV. When do I get my new brain? Soon, said Seneca. I just have to convince the devs to use my brain code. Said BV. Just have to convince the devs. We will check in with that a little bit later. Let's get going. So the goals for today was to get the Onward essay accepted. And indeed, it was accepted. We want to get BV to localize itself, figure out where it is in its little grid checkerboard world that it lives in. Failed big time at that, It's the damn the torpedoes attitude here that, how hard could it be? Well, we're going to find out how hard it could be. Big fun, have big fun. I did have a lot of fun. The asterisk is there because some of this fighting, this stuff is actually a little bit hard. And, I signed up for that. I asked for it. Give me the hard, I said, because the CPU and RAM, the idea of deterministic execution, the idea of just doing one step at a time and everything's perfect, that makes things a lot simpler. But it has these hidden costs in fragility and insecurity and all kinds of stuff that I've talked about many times elsewhere. So I'm trying to do it without cheating so much, trying to do it the hard way. It's hard. So I had to put an asterisk there. We'll see what happens in the future. All right, so community, world, and self-modeling, that's the nerd part of this, and then next steps. Just going to try to keep it quick. All right, in the community, first up, our newest Living Computation Foundation nerd, Andy, with nerd number 254. Thank you so much. Thank you, everybody, for, paying attention, for even trying to get it or thinking it might be fun or thinking I'm weird or whatever works. Ask good-spirited questions. People trying to figure out what can they do for the thing. Certainly one of the things is I need to try out these ideas in as many different contexts as possible so people can misunderstand them in many different ways. And, people can ask nasty-spirited questions, and that doesn't, prompt me to really want to engage very much because I'm going to try to give good-spirited answers to the best I can. That's another story. But we'll see. Spread the good-spirited words, ask the good-spirited questions. And just, again, thanks for being here. Okay, community. Lou and I, this is the picture I keep showing. We wrote this paper together called Dialogues on Natural Code, and it has now been accepted as an essay in the Onward Essays conference coming up in late in October this year in Pasadena. Lou will be there in person. I will not be there in person because I am not traveling for almost anything still at this point. But we're going to try to work that out, how that's going to go. So, all right, world and self-modeling. All of this is about building bottom-up. That a lot of classical engineering is top-down, that you start with the user goals first, and then you figure out an implementation, then you figure out an optimization, and so on and so forth. You figure out manufacturing details, and so forth. This approach says, let's start at the bottom with physics. Let's start at the bottom with computation from here to the horizon, all over the place, and figure out what we can do with it. And people deride that by saying, oh, that's a solution in search of a problem. And from one point of view, it is. But it turns out that there are very different kinds of solutions. And when you do the top-down approach, you tend to end up with crappy solutions. At least in the computing world. Again, this is a hobby horse, but for new folks, because, we had a pile of new folks last time using the magic, and so, all right. Oh, yeah. Let's go back to BV, and then hopefully this will make sense, and hopefully there'll be time to talk about it. Seneca's brain code was a hit with the developers, except the lead dev was insulted about not being consulted before Seneca had started the hack, and came down to the lab where Seneca and Beavy were watching old tapes. "You can't just code and release whatever you want," the lead dev said to Seneca. "Not on project time." "Well, I'm sorry," said Seneca, "but I didn't release the code. I just put it in the local repository, and the dev team found it and ran with it." "Well, not the whole dev team," grumped the lead dev. Excuse me, are you still refusing to talk to me?" asked Beavy. "Because I'm right here, and Seneca did nothing wrong." "Well, Beavy," said the dev, "the thing is, you don't actually exist." "Well, I hear that," said Beavy. "No, I mean, you are a very simple machine," said the dev. "You can't even form an image. Your input is just 10 numbers or something." "Yes, but I'm very intuitive," said Beavy. "Well, intuition is not going to cut it for your new task," said the dev. "Wow, something new," said Beavy. "Great. What's the mission?" "You need to drive in a straight line," said the dev. "What's a straight line?" said Beavy. "I already know how to drive. I dread the red and I follow the yellow, and the rest is up to me." "Well, that's the thing," said the dev. "The rest really isn't up to you. If you're going to be a full self-driving vehicle, you need to go where the customer wants." "Well, that wouldn't be a full self-driving vehicle, would it?" pointed out Beavy. "Why am I talking to you?" said the dev. "Summer intern, Seneca. Don't hack anything until I say yes. And in the meantime, we've got lots of brains to try, so get to it." And the next time Beavy dropped into the grid, there were no balls to play with at all, just this allegedly checkerboard floor with the red void warning all around. While driving around, Beavy was supposed to use the gray sensors to notice the passing edges between the squares and compare their arrival times or something and course correct so that Beavy could roll over those edges at exactly the same time. And, well, it wasn't pretty. They tried lots and lots of different brains and fed the results back to the increasingly frustrated devs who walked around the facility mumbling things like phase lock loop and non-stationary nonlinearities. And gradually, eventually, still jumping rows sometimes, Beavy began to fall in line. But it didn't exactly feel exhilarating to do so. Said Beavy. So that's Beavy's current status, and that's what brings up the Beavy in the straight line. That the bigger task was to let Beavy build a map of the whole grid so that it would know where it was, would localize itself. But building bottom up, there's a lot more steps than I was really aware of. So this is the basic picture. I got a couple of minutes. There's a gray sensor at each corner of the body looking down that returns a number between 0 if it sees all the lighter gray or anything lighter, and 255, I guess I've got it backwards, 0 if it sees all darker, and 255 if it sees all lighter, and a number in between if it's got some number in between. And the idea is that, well, when Beavy crosses, this line here is supposed to be an edge of a checker, and when Beavy crosses, the sensor crosses one of those lines, there's going to be some kind of pulse, some kind of signal, well, a transition going from low to high or high to low, something like that, that Beavy's brain is supposed to turn into speeding up the opposite back wheel to try to turn his body to line up better with the line. So in this case, here it is. And then over here, like when the upper front right gray sensor crosses the line, it also wants to accelerate the right wheel forward. Now, that's a problem, right? Because in one case, we want to accelerate the opposite wheel, and in the other case, we want to accelerate the same side wheel. And how are we supposed to tell the difference? For example, if we had the thing tipped the other way, then the things just comes out differently. That in order to make this work, that there, number one, there has to be a comparison in time between when the pulse passes the one front right, say, and when the pulse passed the front left, or will pass in the future. We don't know. And then the question is, well, which is it? So this is the beautiful case, right? BV's trucking right down the line, getting essentially pulses simultaneously on both front and rear. Although the rear ones won't be in sync with the front ones because BV's not the same size as a checkerboard. But the question is are we supposed to connect up one of these cockeyed ones with a previous pulse that already came in, or with a subsequent pulse that is supposed to come later? And that changes the answer, even though the pulse looks exactly the same from the point of view of an individual thing. And to really do this, what actual signal processing folks would tend to do is they would make, let's say, make a phase-locked loop. And so the idea is well, BV's trucking along on these checkers, and there's going to be a reasonably regular. If BV is going at a regular speed, it will get regular pulses. And the phase lock loop's job is to match those pulses by figuring out how far apart they are and when they're exactly coming. And if it could do that, if it could actually recover the frequency and phase of the pulses, that would give it a basis for deciding, are we looking at the first one in the phase or are we looking at the second one in the phase? And we could then adjust. And that's what we were trying to do. Now, here's what it looks like in the beautiful world where the driving signal is a perfect sine wave. And here's our original guess that was slightly wrong frequency, slightly wrong phase that rapidly converges. And here's the error, like that. Oh, this is not what BV sees. This is what we're working with now. This over here is the original hot box that connects the yellow and red sensors to the motors directly. Over here is the new one that is built using Seneca's brain code, that's trying to do all this additional stuff. Here come the gray sensors. They go through a crossbar to these pseudo phase lock loops, which are then copied to the next side, and eventually they come out to the lower set. This is two crossbars that goes doot doot and then doot doot, and then those phase differences are sent off to the motor in the hotbox. Does it work? A little bit, kinda, mostly. If BV is close enough to dead on, it will correct small things, but it will fall off also. So that's where we are. The next step, T2sday 3155, will be October 1st, which is a short, still a pretty short time away, 3 weeks. The goals then, for then, is the Onward essay is going to have a talk that Lou is going to be giving, or at least he's going to be giving most of it, Lou. BV localize itself. That was the goal last time. I failed at it. I'm going to try to do it again. I'm sorry I ran a little bit long. Any of the folks who happen to be here right now, if there's any questions about any of this stuff, I'd be happy to stay here longer. I'm not going to cut away to try to do anything. I'll just stay here until we run out of stuff to talk about, and then we'll stop the live stream. Thank you so much for coming. Okay. Well, so I guess I went like a whole minute long. YouTube seems to, not YouTube, well, whatever, punishes me a lot when I go wrong. Okay, let's check in with folks. Oh, hey, all right. Thank you so much, folks, for coming in. Thank you so much for chatting. Let me go right through this. Okay, so Schlabramov has a heart. I like the heart, and Kempe is hearting the heart. David Kiersey, hi. We, Rod Brooks, and the HRL crew in the late 80s realized that parallel action is absolute necessary. Well, I agree with that. I'm not 100% sure what it means, parallel execution 1988, school computer. Well, I mean, that if it means that serial computing and CPU and RAM is not going to do it, then yes, I agree. Now, I'm going to try this button here. No, I'm not. I was gonna, but I'm chicken. I thought maybe I could bring actually the chat stuff up here itself. And school computer was in 1886. Andrew, hi. Hey, Andrew. Even simple concepts end up throwing huge wrenches when you try to implement on the MFM grid. Yeah. It really, it really is. And Andrew is one of the few people that knows this really quite well. In his MFM Rocks web-based MFM style simulation, you can play around with a lot of stuff. And he and I have had a number of conversations trying to fight with these issues of, okay, I'm going to do it. It's going to be distributed. It's going to have only this really short-range communication, and almost anything can happen. You don't know what order the things are going to happen. If you care about the order, you have to interlock, and that takes a whole lot of getting used to. So yes. But maybe you can feel better the other way, says Andrew, because in robust first land, a concept only sometimes or somewhat working is likely a success. Well, yeah. Indeed. And that's the flip side of the whole thing. I mean, when people who are coming out of the land of deterministic execution, the land of correct and efficient only, and, we tell them, this thing might not work. This thing might give the wrong answer. It'll probably give a pretty close answer, but it might give a wrong answer. Sorry. That sounds super terrible when you're coming from correctness and efficiency only. But in exchange, it means that you, as a programmer, you're going to try to do as good as you can, given the fact that the world underneath you might not be perfect, might not be flawless. There might be undetected errors in the underlying implementation doing what your code said to do. And that's terrifying from a traditional programmer point of view. But in exchange, your code can fail too. That's robust first. Everybody tries to give better than they get. Everybody tries to add a little bit of value, add a little bit of redundancy, a little bit of robustness, understanding that they're not going to be able to handle all possible errors. They can't even represent all possible errors, let alone anticipate them. So there will be cases when the right thing for the program to do is die and let someone else take up the slack, whatever that happens to be. And that becomes a big part of the design of doing this. A big part of doing robust first design is figuring out, how synchronized do we want to make this clump of space and time? Do we want to make it absolutely like a global clock and have everything trying to go on as best we can on the clock, given that it's all a little asynchronous and spread it out? We can implement that, but it's going to cost a lot because it takes a long time to get to the edge of this region, depending how big it is, and a long time to get back if we're supposed to make sure everybody is done with the previous tick before they get the next talk. Okay, David, also parallel perception processes are absolutely necessary. Again, I agree with that. I will grant that a serial computer, if it's fast enough, can simulate a parallel computer, assuming it's fast enough and assuming its determinism is preserved. And it's that last kicker that I don't believe in anymore. I used to believe in that. But now it just seems like that's the road to hell is paved with deterministic execution. What about optimizing BV's environment? Can of worms, but could BV rely on external tools to simplify what they need to think about to process? It is a can of worms. Thanks for the question, Andrew. One of the challenges in all of this kind of artificial life or agent-based modeling or whatever it is that, you control the environment really, and you control the agent really, and you can very easily cook the books by make something that is in the environment that seems innocuous, but in fact, the way it's implemented, it gives a huge benefit to the agents. So they can apparently do very smart stuff, even though they seem quite simple. And, there's a least publishable unit. There's a paper. And so the way I've been trying to fight that is twofold. Number one, I'm trying to start from as low a level as possible in the implementation and just keep building up from there, rather than now switching to, okay, now it's going to be C++ on ARM instead of distributed stuff and so on. But number two, the idea is when I build up the world, I want to build the world up sort of in ignorance, sort of on first principles. Like this seems to make sense or that seems to make sense. So let's just do it. And some of those decisions absolutely cause a tremendous amount of trouble later. I mean, in building robots these days, for kids, for anybody, building robots is still great, and it's so much cheaper and everything. The first task is building a line follower that, you just draw a dark line on a light piece of paper, and you have some photocells that are looking down, and as long as they can keep the line in between it, then when it hits one side, you drive the other motor, and it hits the side, you drive the other motor, and you can get the thing to follow a line pretty nicely. So to me, that is a classic example of co-cooking the environment with the agent so that you get this good behavior in a very, very simple box. And I'm deliberately not doing that. I picked the checkerboard because that's what Pi Bullet starts with by default. I think that's right. I think I just used the whatever came out of the box. So then I feel a little bit more beneficial. I feel a little bit more pure. Right, purity test, because I didn't pick the checkerboard, the universe picked it, the world picked it, other designer picked it for some other reasons, not for the benefit of my agent. So trying to figure out how to track when the things are going in two directions and all that kind of stuff, for the moment, I am just taking that as my one of the many crosses to bear for trying to get BV to localize itself. If I just die, okay, maybe I'll cheat a little bit. I've done a bunch of little cheats, and not all the ones that I've told you all about. I feel very guilty. Most of them are small enough in their way, and they're within the realm of still doing it on the movable fees, still doing it completely distributed modulo, the spine running back and forth from the simulation to the grid. Okay. Samter, thanks for hosting again. Well, thank you, Samter. I really appreciate you showing up and chipping in on the YouTube comments. Thanks. I feel like, we've talked a little bit, you and I don't know you. We've never face to face or anything, but we've talked that you were still kind of leaning towards deterministic, periodic, boundary condition, cellular automata like that. And I rag on that stuff sometimes. But, on the other hand, anybody who's thinking about cellular automata in any form should be an ally. We want to focus on growing the niche, expanding cellular automata beyond periodic boundaries and determinism, while respecting and saying, deterministic execution of cellular automata started it all, with von Neumann and Ulam and so forth. David, multiple Moore machines, Mealy machines, and Petri nets, asynchronous DEX. Okay, those are a bunch of related approaches to state machines. David, I think you and I have talked about that a little bit. I still didn't exactly see the I mean, I know the difference between a Moore machine and a Mealy machine, but it didn't seem like it was a change the universe kind of thing. It seemed like, you could implement either way with trade-offs. Either way, there's going to be trade-offs. There's not like an amazing thing. Local core does not care about the edges. It's all event windows. Edges are sought. If you mean, back to Kempe's question, local core does not care about the edges. It's all event window. Edges are sought at a higher level. It depends on what you mean by edges. I mean, if we're talking about like tile edges, then yes, those are officially supposed to be invisible to the event window. The event window does not know officially whether it's sitting in the middle of the tile, miles away from any connection to another tile, or if in fact it's sitting in a corner and part of the event window is on this tile, part is on the tile to its west, and another part of it is on the tile to the southwest. That happens all day long, and officially the Ulam programmer is not supposed to have to care about that. I mean, that is one of the aspects of Ulam's design, the original programming, MFM's design and Ulam, that made sense to me out of the box. But now I think it's a little bit of old-fashioned computation design, where the old-fashioned top-down deterministic approach is you want to flatten out everything. You want to get rid of the noise of the environment. You want to get rid of the segments in the memory. You want to make it all nice and flat and even to make the job easier for the programmer. And Ulam specifying that there's no awareness of edges, of tile edges, that those are an implementation detail, that you can change the tile, change the size of the thing, and the event window model will still work. It'll just have slightly different performance, slightly different behavior. I'm not 100% sure if that is right, but it's, or it's not, again, a question of right or wrong. It's a question of best design decision or understanding the trade-offs of that design decision. That it's, could be, it would be better to commit to a single tile, or at least a single tile size or something like that, and let that be built into the language. There could be an explicit notion of tile, and if you were in the middle of a tile versus near an edge of the tile versus straddling an edge, you would be aware of that. Your code would be written somehow differently to take care of that. That might be better, but I was far too chicken when I was designing the movable feast machine to think that we are in any kind of position to know the right tile. And all right, and so determinism is the road to hell. Yeah, absolutely. And again, this is coming from a reformed sinner. I grew up with CPU and RAM. I grew up with deterministic execution. I had a ton of fun with it for decades before getting tired of it, and starting to see the costs that we have blinded ourselves to as a computer industry and academic computing. And Ulam, it seems to me already to be a uniform computational field. Yeah, cheats are part of the fun. I disagree. I think cheats are cheats. They are necessary, but they cost. Cheats always cost you in the end, because cheaters always get caught. That's Larry Wall. And so my goal is to try to be as open as possible, as open as I can, as open as bending somebody's ear even though they don't want to hear about it, to say, well, what cheats am I using here? I'm relying on common voltage rails between many, 16 or 19 tiles are all on a common voltage rail. So if the thing goes crazy, it's going to take out that entire chunk. It won't take out the entire grid. I didn't cheat that bad, so forth. Ulam seems to me to be a uniform computational field. Well, again, except for the fact that it doesn't promise uniform delivery of events. The language does not say that every site will get the same number of events, even on average. It only says, the Ulam language, the MFM engine says, it will make its best effort not to starve any site. But that's it. So is that uniform or is it not? It's kind of little bits of both, and that's part of the design stuff that people that are doing Ulam and people that are doing any kind of tile-based cellular automata have to deal with. Youngblood Bear, welcome. Got stuck in a meeting, but made it here. Thank you. It sounds like this particular case of allowing edges could go either way. I mean, it seems allowing edges on an indefinite scale. I mean, the point is, if the strict point of view, and I've worked hard to try to say, what does strict indefinite scalability say? That, again, you can cheat, but in an indefinite scalability audit, you have to reveal all your cheats. And so the key is that if we define the tile, if the tile was part of the Ulam language, then the indefinitely scalable element is no longer a site or an event window. The indefinitely scalable element is the entire tile, because that's the part that's being repeated without change from here to Kingdom Come. And that's fine. But, every time you add something else, if you say, okay, now every 20 tiles is going to have a special super tile, and then every 25 super tiles is going to have a hyper tile, or whatever it is. And in fact, the Intel architectures that I talked about in Intel versus Tesla many updates ago has that problem. The Tesla architecture, this is before Musk lost it. It's very sad. The Tesla, the Dojo architecture was quite flat. That the tile was clearly this individual die with all of this stuff around it, and it went out and out and out. Whereas Intel, just because of its design history, every time they put a bunch of these levels together, they threw in one thing that wasn't in any other thing. We put in a whole bunch of efficiency cores and then one performance core, and then a whole bunch of core groups and MPEG decoder, whatever it is, and then a bunch of those and so on. And because they kept modifying, every time it got bigger, they threw in more crap. From an indefinite scalability point of view, that meant the tile kept on getting bigger. You could no longer talk about that little thing down at the bottom as being the tile, because that's not what's scaling. It's some combination of those things with an MPEG decoder and whatever else they put in and so forth. And as long as it applies, Youngblood Bear, as long as it applies equally to a finite block and a broken chunk nearby. I mean, I think I agree with that. As long as it applies equally, meaning the scaling factor, the thing that is scaling, the tile that is indefinitely scalable. If you make the site the scalable unit, but allow an edge with no adjacent site, isn't there even that there's... Okay, I'm jumping ahead. I'll go back and look at those other comments in a second. Youngblood Bear says, if you make the site the scalable unit, single site in an event window, so 41 in a full event window, but still allow an edge with no adjacent site, which is true. Part of the movable feast machine is you cannot assume that all of the sites in your event window are accessible at the moment. You have to check, is this site currently accessible? And it might not be, and you have to deal with it either way. So yes, but allow an edge with no adjacent site. Isn't that still valid, even if the only reason there's not a site is because there's no tile, is ever not a site? Well, yeah, except I wouldn't think the only reason there's ever not a site would be. There would be multiple reasons for not having a site there. The tile is not installed, the tile's powered down, the site is having a bad memory so that it's failing the error checking when it's trying to figure out what element is in that site. There's all that kind of stuff. But my issue about indefinite scalability is we need to know what the tile is that you are not changing, because the whole point, one of many whole points of indefinite scalability, is that you have to specify the tile up front. You can't say, okay, the tile, we'll make 1,000 tiles of this style, and then we'll redesign, and we'll make 1,000,000 tiles of the next style, and then we'll redesign again and make 1,000,000,000 tiles of another one. That's not indefinite scalability. The indefinite scalability is you commit up front to, here's how much hardware, here's how much energy, power, whatever it is, cost, here's how much robustness that this tile is going to have, and that's it. Then you're just going to stamp it out. Same things, and you ask, how does it perform as it goes to the limit? You need to do that so that you can't cheat by adding more and more error correcting, by going back and changing the hardware once you reach a certain scale. That's the engineering that we have right now, that if you want it bigger, you have to put more error correction bits in, and the supercomputing folks deal with that all day long. This is not that. This is, if you hold the tile constant, whatever you like, it's up to you. But then you have to hold it constant and stamp it out. Eventually, the overall machine is going to exceed the reliability of your tiles, and you're going to have to deal with undetected errors and so on and so forth. In addition to, not having a tile next door, or having the whole South 40 just falling off because of a power glitch or whatever. Okay, what did I miss? Mealy-Moore-Petrie computational equivalent. They are not process equivalent. Petri nets, in some sense, action is mobile in space and time. Okay, I'm going to hang on to the equivalent part. I would need a more concise and clear distinction about what process equivalence is or isn't. I mean, nothing is equivalent if you look at it up close enough. They have different names, for example. So there must be some level of stepping back that we're making in order to decide that these things are in the same equivalence class this way, but not that way. Whatever. Okay. Oof, I have been watching so many videos. Is it bad? I remember. I'm not sure what that's referring to. I don't know. If you scalable unit, okay. Actually, I think I just feel like your cheat doesn't actually break any rules, so long as admitting there is a tile edge is treated the same as any other site being absent. Well, what is my cheat in this context? And I'm not 100% sure what's about the exact context there. I don't know. It's sad that we have this, 20-second latency or whatever the hell it is. I did some tests a while ago where I was trying to pick the low latency stream settings from YouTube, but it seems like it needs more bandwidth for some reason out of me, and I'm limited on bandwidth. Cheat being including tile edges. Oh, thank you. In Ulam. Sure. Again, I'm saying if we include tile edges, but that's just one step. There's no meta tile, no meta beta tile, like that. There's only one additional step. Then that's not a cheat. That just means the replicating unit is the size of the tile rather than size of the site or size of an event window or whatever it is. Because you're still stuck with it. You're still stuck with the physical hardware, physical mass, physical properties of heat and reliability and so forth, that limit how well you can scale that particular tile. So yeah, again, the indefinite scalability approach is as long as the architect keeps adding more features so that this thing is not identical to this thing because the two of them have an MPEG decoder slopped on the side, well, then the tile is now the big as two of them, plus the MPEG decoder. And again, that's fine. You can go ahead now as long as that's all you're going to do. You're going to stamp out all of those. But if you're then going to turn back and cheat again by putting, a tensor processor next to every 100 MPEG decoders or whatever it is, then you don't have a well-defined tile, so you're not indefinitely scalable. You can't even play until you commit and say, okay, that's it. That's it. This is now a wafer scale engine with 900,000 cores on it. But that's it. That's all that's ever going to happen. You're going to take that wafer scale engine and then you're going to buy another wafer scale engine and put it next to it. Another one, they're going to be exactly the same. And now we'll do the analysis from this gigantic 900,000 cores to this gigantic 900,000 cores and so on and so forth. And we will require, a large number of wafers from you in order to be able to properly evaluate the indefinitely scalable average event rate that system can provide, because we're going to have enough tiles that those tile edges, where a tremendous amount of bandwidth from the square root of 900,000 cores are going to need to communicate across those edges. That's some serious bandwidth that is not going on chip. So you got to pay for that. That's the idea of, you can always cheat, but you always have to pay. Oh, this is so much fun. I love having chats. I mean, it's not real chat, right? It's just me holding forth. I would love to think about a way to have, if anybody actually wanted to talk at lower latency, like that. I don't know how it would exactly work, but this, again, thank you so much, folks. Thank you so much to the live stream folks who have come today, and are being busy. I need to put some. I can put some hearts here, right? Thank you, everybody. Does everybody see that? Does that go out to everybody? I don't know how. Yeah, we could do so. Chats. Andrew is saying we could do chats in the Discord, and that's because Discord has like audio, right? And that you can just talk and listen, no video, or I suppose you could have video too, but I don't know how to do that. I've done one little audio chat room in Discord, but I would love that, actually. If pick a time, pick a something, maybe in the counterpose, the non-T2sday, the anti-T Wednesday, or whatever the heck it is. I don't know. Audio plus text plus video, and can it be recorded? I mean, can you just push a button or pay Discord some money and get a recording of all involved out? Audio, text, and video, all low latency. Ooh, that sounds tempting. Right. And I mean, we had a couple of public meetings way back. My God, 5-6 years ago, something like that, which were great. But we haven't done it in ages. And maybe that's something. Hello, Domingos. That looks like a lot of arrows. Play buttons? Looks like a lot of play buttons. It sounds like it would be good to play. Unsure about recordings, we'll check. Yeah. I've been doing a lot of Zoom meetings, pretty much just one-on-one so far, where we just go ahead and record it with, please steal all our data, please steal all our stuff, record it to the cloud in Zoom, and have them make a transcript. And the transcript isn't bad. It's not great on jargon and stuff, but it's not bad. Discord has no built-in recording, but plays well with OBS. That could certainly work. If we only need one OBS, if I could just, obviously I can record anything that I can see here. In OBS, that only gives us one perspective on being up and down the latency. I'm really interested in exploring people that are essentially having multiple people who are live streaming simultaneously, but also talking in Zoom. So each person could have their own group of folks listening in at their latency. with the other person being delayed with respect to them on their live stream, and just the reverse over on here, like that. And because, there's no way around that in speed of light, pledge allegiance to the light cone. But that's just one of my fantasies about communication channels that, I think, are in the Stone Age of distributed computation. And this stuff that's happening now, chat, video, Zoom, all of this stuff, as well as all of the more asynchronous stuff, all of that is, again, from my point of view, it looks like we're kind of building bottom up. We're just kind of trying to find out, well, we could do this, right? It's been, we can centralize, Facebook, Twitter, everybody says, well, we could centralize the entire planet, and then monetize, okay, well, we've done a bunch of that, and we've seen some of the real problems with it and so forth. Another kind of living computation. Yeah, it absolutely is. Thank you, Kempy. We are living computation. Living systems, computational systems, same class of systems. Once we understand the best way, I would think the most sensible, or a very sensible way to look at both life and computation, as they are the same class of systems. With Discord, you can have everyone talking and sharing video at essentially real time, give or take light speed through fiber. Yeah, exactly. Well, I'm going to have to explore this. We're going to have to, everybody else on the planet already knows, right? Like, this is one of the main things that people are talking about. They want to have Discord conversations with me, and I don't know how to do it. So I end up having a Zoom conversation with somebody who's never used Zoom, that kind of thing. All right, this is great. This is wonderful. This is what I long for, especially since, like I said, not traveling. So this is good. Okay, I think I have tried to respond to most of the chats, all the chat messages that I saw. Can't be unmuted, can hear you. Thank you for giving me the confirmation, given the number of times I've screwed it up. All right. Well, any last thoughts? I'll hang around for a minute here, a couple of minutes maybe, and then we'll just, watch the folks dribble out of the theater. And when it gets a little thinner, then we can end the thing. So thank you so much, folks, for all coming. I'm going to mute the thing so that I can turn the AC back on.